Gas exchange involves the diffusion of gases. In the lungs, this diffusion is called external respiration, and it occurs between the alveoli and the pulmonary capillaries. The diffusion of gases occurs across the respiratory membranes, and each gas will diffuse along its own partial pressure gradient. The partial pressure of oxygen in the alveoli is going to be greater than the partial pressure of oxygen in the pulmonary capillaries. This is due to the fact that there is more oxygen in the air that is being breathed in than in the blood that is returning back from the tissues. So oxygen diffuses out of the alveoli into the blood. Carbon dioxide will follow its own partial pressure gradient as well. Blood returning from the tissues will be higher in carbon dioxide than the air in the alveoli. Therefore, the alveolar partial pressure of carbon dioxide will be less than the capillary partial pressure of carbon dioxide. Gas exchange at the tissues is called internal respiration. Each gas will diffuse along its partial pressure gradient across the endothelium. Oxygen has a higher partial pressure within the systemic capillaries and therefore will diffuse out of the blood into the tissues. When the oxygen gets into the tissue cells, it is used during aerobic cellular respiration to synthesize ATP. This helps maintain low levels of oxygen in the cell and thus the partial pressure gradient. Carbon dioxide is a waste product produced during aerobic cellular respiration, and so it builds up in the cell, increasing the partial pressure of carbon dioxide within the tissues. Carbon dioxide will move along its partial pressure gradient, diffusing from the tissues into the systemic capillary. So the capillary partial pressure of carbon dioxide will be lower than the tissue partial pressure of carbon dioxide. The highlighted yellow areas will show you the partial pressure of oxygen in the alveoli and in the pulmonary arteries. You'll notice that the partial pressure of oxygen in the alveoli is 104 millimeters of mercury, whereas in the pulmonary arteries it is only 40 millimeters of mercury. Therefore, oxygen will diffuse from the alveoli into the pulmonary capillaries. Carbon dioxide, on the other hand, which is highlighted in purple on your illustration here, has a partial pressure of 40 millimeters of mercury in the alveoli compared to a partial pressure of 45 millimeters of mercury in the pulmonary arteries returning blood back from the tissues. Hence, the diffusion of carbon dioxide will occur from the pulmonary capillaries into the alveoli. Let's look at the oxygen diffusion. At the tissue levels, notice that in the systemic capillaries, the partial pressure of oxygen is 100 millimeters of mercury, compared to a partial pressure of only 40 millimeters of mercury in the tissues. Oxygen will leave systemic capillaries and go into the tissues along the partial pressure gradient. The turquoise highlights show the levels of carbon dioxide. In the systemic arteries and thus the capillaries, the partial pressure of carbon dioxide will be 40 millimeters of mercury, compared to a partial pressure of greater than 45 in the tissues. Hence, carbon dioxide will move from the tissues and diffuse into the systemic capillaries.